Okay, so today we're going to be multiplying matrices. The first thing we want to do when we are multiplying matrices is we want to check the dimensions of our matrices, because matrices aren't like regular numbers. You just can't multiply any matrix times any other matrix you want. You need to check the dimensions. You're going to see why in our first example. But here's the rule. If A is a matrix and its dimensions are m by n, and the matrix we want to multiply it by is n by p, then the product is going to be m by p. Now I want you to see something. If we write these side by side, A is m by n and B is n by p, you can see that the two in the middle match. The columns in A have to equal the rows in B. If the columns in A don't equal the rows in B, we can't multiply our matrices. And if those match, then it's almost like these kind of go away, and our new dimensions are going to be the rows in A, by the columns in B. So let's take a look at our first example. We have two matrices we want to multiply. A is 1, 2, 3 rows by 1, 2 columns. And B is 2 rows by 2 columns. As you can see, the number of columns in A matches the number of rows in B. And so our dimensions are going to be 3 by 2. That's the first thing we need to check. Alright, now that we've checked to make sure we can actually multiply our two matrices, I'm going to erase this. Remember, if at any point I'm going too fast, you can always pause the video and go back. And we're going to multiply. When we multiply matrices, we multiply them row by column. So we circle the first row in A and the first column in B. Our first product is going to be 2 times 4 plus 1 times 2. I want you to notice that I'm multiplying the corresponding entries, the first, and then the second, and the second. I'm going to have two matrices here. I'm going to have one with my work, and I'm going to have one with my final answer. So my final answer is going to be 8, 9, 10. Okay, so because this was the first row and the first column, my answer goes in the first row and the first column. Erase this. Now I'm going to go to the first row and the second column. And I'm going to do first row, second column, 2 times 3 plus 1 times 0. Well, that's going to be just 6. So that goes in the first row and the second column of my answer. I'm all out of columns, so now I'm going to move on to the second row. I'm going to take the second row and the first column, and I'm going to do -2 times 4 plus 0 times 2, and that's going to give me -8. Now I'm going to do the second row and the second column, and put that in the second row and the second column of my answer. So -2 times 3 plus 0 times 0 is going to give us -6. And then we're going to do this third row. And the first column, 0 times 4 plus 3 times 2 is 6. And now the last row with the last column is going to be 0 times 3 plus 3 times 0 is 0. And here is my answer. Okay, so what we just did there was A times B. Let's see if we can do B times A. Now, I'm going to make a mistake on purpose. I want you to watch what happens when I do B times A. If I try to do B times A, I would take the first row of B and the first column of A. And look what would happen. I would have 4 times 2 plus 3 times negative 2. And then you'll notice I'm kind of all out of numbers in my row, but I still have the 0 left in my column. Why is that? Well, let's look. Matrix B has dimensions 2 by 2. Matrix A has dimensions 3 times 2. Do the insides match? No, because the number of columns in our first matrix does not equal the number of rows in our second matrix, there is no product possible. Alright, so let's look at some other examples. State whether the product AB is defined. If so, give the dimensions of AB. So when we look, this should go pretty quick, because right here we see they don't match. No. Oh, these match, so my product will be 3 by 3. These match, so my product will be 3 by 1. 3 by 2. Oh, they don't match. These match, so my product will be 3 by 5. Didn't leave myself enough space there. Oh, these do not match. These match, so my product will be 2 by 4. And then these match, so my product will be just 1 by 1. That's a fun one. Alright, find each product. If it is not defined, state the reason. So the first thing we're going to do for number 1 is we're going to check the dimensions. So number 1 is 1 row and 3 columns, and then we have 1, 2, 3 rows and 2 columns. So here they match. And we know our answer will be 1 by 2. So we'll do this one together. We have 1 row, and then we're going to do that times the first column. So it's going to be 2 times negative 1 plus 3 times 0 plus 4 times 5. And when we do the arithmetic, we get 18. Now that went in the first row in the first column. Now you'll notice I only have 1 row, so I really don't need this much space in my matrix. I know my answer is going to be 1 by 2, so I'm just going to make my answer 1 by 2. Alright, so I'm going to go to the next. I have 1 row times my second column is going to be 2 times 4 plus 3 times 1 plus 4 times 2 is going to be 8 plus 3 plus another 8 is going to be 19. Alright, pause the video and try problems 2, 3, and 4, and then I'll put the answers up for you. Okay, so here are the answers for these problems. Pause the video and check your answers, and if you're having major problems, you should come see your teacher at lunch. That would be me. Alright, let's take a look at one word problem that we could use to illustrate why multiplying matrices is an important skill. So, let's say we have a shirt company and we are manufacturing our shirts. We have 3 different styles of shirts, maybe they're 3 different sizes, and each shirt style requires a certain amount of fabric, a certain number of buttons. What we're going to do is we're going to use matrix multiplication to create a matrix that gives us the cost to produce each shirt. So our first matrix gives us style, we'll call this style. So we have style by, we'll say, fabric and buttons is materials. Now, our second matrix gives us the materials by price. So look, the insides match. the number of columns in our first matrix equals the number of rows in the second matrix. So if I multiply these two matrices together, my answer will give me a matrix that gives me the style by price. In other words, I will be given a matrix that has the price for producing each shirt. So here we go. 5 and 4 by $2.50 and 25 cents. So if I do 5 times $2.50 plus 4 times 0.25, that's going to give me 13. Oh, you don't really need that. 13.50. Okay, and that's going to be for shirt A. Now, if we do shirt B times our column, if we do 6, I'm not going to write all this out. 6, well, might as well. 6 times 250 plus 5 times 0.25. That's going to give me 125, 1625. And then our last one, if we do 8.7 times our prices, that's going to give us 21.75. So what we've done using matrix multiplication is we've created a matrix that gives us the prices of our 3 shirts A, B, and C.